Hi, this video is going to be on every operation having to do with decimals. Adding and subtracting, multiplying and dividing, and that's basically it. So we're going to jump right in. The first set of examples, I know this is example number 1, but it's 3 parts to it, are basically adding and subtracting decimals. So the key to adding and subtracting decimals is you got to line up the decimal. So here we go. 41.6, and just go with the line up method. 41.6 plus, now if I put the 2 and the 4 right here, the decimals don't line up. That is the main issue. The decimals have to line up, guys. They got it. They got it. So here we are. I'm going to put the decimal first. After that, I'll put the 3 down, and then the 42. Now, if you're noticing, right off the bat, hey, there's no number right here. That's right, there's no number. What number comes to mind that means nothing? 0. Gotta add a 0. 0 plus 2 is 2. 6 plus 4 is 10, carry to 1. 1 plus 1 is 2. 2 plus 3 is 5. And by the way, don't forget to bring that decimal down. It lines right up with these two. That's it. Okay? And then there's the 4 right there. 4 just comes right down. So the answer to this one, 41.6 or 41 6/10 plus 3 4200 or 3.42 is equal to 45 200 or 45.02. So, and that's it. Now let's just keep on going. Example B of part 1. Let's say you owe someone $39.20. You're able to give them $16. What do you still owe them? It's just like integers. If I had, let's say I had -4 plus 19. If I owe someone $4, I'm going to give them $4. Now I'm losing money, right? So this would be, so really all I'm doing is 19 minus 4. Okay? 19 minus 4, which is 15. Always take that big number minus the little number, and the one that wins the tug of war is the one with more power. Are there more negatives? More positives. More positives, so this would be positive 15. So going with that idea, I owe someone $39. If I'm giving them $6, I'm losing $16 that I owe them. Sorry, let me phrase that. My amount of debt is decreasing by 16. So I'm still going to owe them money, but I owe them less money now because I made a payment. So in general, so what I mean by that is, well, I'm just going to take 39.2 minus 16. By the way, where's the decimal on the 16? It's a whole number. The decimal is always at the end. So like 16.0. Here we go. 2 minus 0. And by the way, you might as well just put the decimal down there if you forget. 2 minus 0 is 2. Okay. Decimal. 9 minus 6 is 3. Okay. 3 minus 1 is 2. So when I write this, here we go. 23.2. Oh, a little more space. Now here's the question. Are there more negatives or more positives? 39 is bigger than 16 by a whole lot, so there's more negatives. So my final answer would be negative 23.2. Coming on down here, just keep on going. I owe someone $19. I borrow or I take away another $29 that I don't have. So now I owe them even more money. Here's another way of writing it. I like to say 19.8 is like adding the opposite, like minus, right, is adding the opposite. 29.62. Big on that one. Which for me, I owe someone $19. I owe them $29. I owe someone else $29. So I'm putting my debt together. So I'm making a pile of negative and then a bigger pile of negative. It's not getting smaller. It's not decreasing. It's growing. So here we go. 19.8. So I'm adding because it's growing. Plus, well, here's my decimal. Got 29.62. There's no number right there. Again, when no number goes with no number, put a 0 right there. 0 plus 2 is 2. 8 plus 6 is 14. Carry to 1. Bring down the decimal. 1 plus 9 is 10. 10 plus 9 is 19. 1 plus 1 is 2. Plus 2 is 4. So this is equal to 49.42. But go back to my debt analogy. I owe someone $19 and I owe someone else $29. So in total, I owe someone $49.42. That's my final answer. Okay, by the way, make sure you box all your answers. Tip your waitresses, ladies and gentlemen, tip your waitresses. So lining up the decimal, you guys should, this is a review. This is something that you've been doing for a while. You've been doing decimals for about 2 or 3 years now. So this is just a little bit of a refresher, and it's including it with the integers and positives and negatives. But it's not integers. Remember, they're rational numbers. Decimals are just a fancy way of saying it. Next set of examples, we only got 2 more to do. Breakdown. And so this is with multiplying decimals. You don't have to line up a decimal when you multiply. 18.3 times negative 4.09. Positive times a negative is a negative. I know my answer is going to be negative something. I can answer that first. That's my first part. I'm going to cancel out any positive answers I see on a multiple choice test. It's got to be a negative. All right. 18.3 or 18 3/10 times 4 9/100 because it's 2 decimal places. And you might be saying, hey, Mr. V, you're making a pretty big deal about these, like 0.3 is not 0.3, it's 3/10. For this, it actually is kind of a big deal. Let's come on over here. I'm going to take 3 times 9. And I know 3 times 9 is 27. But I don't want to show this carrying stuff. I'm just going to say 27 flat out. 3, that 0.3 is really 3 over 10. And that 0.09 is really 9 over 100 as a fraction. Well, 3 times 9 is 27. 10 times 100 is 1,000. So 1,000th as a decimal, well, that's like 0.001. That's 1,000th. Well, we've got 27 thousandths, so we just need to add one more 0 and put the decimal right here. So that's what that means. Kind of a little different way of doing it, but I really like this way. It takes some getting used to. I'll do the classic regular way that you guys are familiar with, but I'm showing this one first. 9 times 8, well, it's not 9. Remember, it's 9/100 times 8. Well, 9 times 8, I'm going to put a 1 underneath this, right? Because it's a whole number. 8 is a whole number right there. 9 times 8 is 72. And this is 100. So this is 72 hundredths. Okay? 9 times 1, that's not, now that number, it's not 9. It's 9 hundredths times 1, that's not 1. Look what places did. This is those singles, and this is the tens place. So it's really 10. 90 over 100. You know and I know zeros cancel. So it's really 9 over 10. So this is 0.9 because it's 9 tenths. 0 times anything is 0. We're skipping that. Now we've got, let me zoom out a little bit. I know what you're thinking, man, you're doing a lot to show this. Oh yeah, I am. I've got 4 times 0.3. 4 times 3 tenths. The one underneath that, this is 12 over 10, which is 1 and 2 tenths. And if you remember from your converting fractions, that's 1.2. 4 times 8, just do it. 4 times 8 is 32. 4 times 10, because remember that's 10. 4 times 10 is 40. Here we go. Now we're adding 0, 0, 0, 0, 0, point, 0, 0, 0, 0, 0, 0. Here we go. 7 plus 0 is 7. 2 plus 2 is 4. 7 plus 9 is 16. Plus 2, 18. Carry to 1. 1 plus 1 is 2. Plus 2 is 4. Oh, by the way, decimal. Don't forget the decimal. And then 3 plus 4 is 7. So the answer should be negative. Oh, there's that negative right up there. Don't forget that negative. Huge problem of missing 74 and 847 thousandths because it's 3 after the decimal. So my answer is negative 47.847. Another way of saying it. Breakdown's really neat because it actually shows, it actually lines the, did you see how it lined the decimal up for you? Now let's go with classic. And this is kind of something that's a little sketch in my mind. Okay. Oh, don't forget that decimal. 9 times 3 is 7, carry to 2. 9, and here I'll zoom in for this so we're not distracted by everything else going on. I'm all over. 9 times 8 is 72, plus 2 is 74. 9 times 1 is 9, plus 7 is 16. Add a 0 place, but that's 0 times everything, so who cares? So we're gonna add, so I'm just gonna leave that as 0. I'm gonna add 2 zeros now, because of the 4 is the third number. 4 times 3 is 12, carry to 1. 4 times 8 is 32. 32 plus 1 is 33. Now we're carrying a 3. 4 times 1 is 4, plus 3 is 7. 7. 4 plus 0 is 4. 6 plus 2 is 8. 1 plus 3 is 4. Bring down to 7. Not done yet. 1 decimal place. 2, 3. So we got 1 and 2. Makes 3 decimals. So here we go. 1, 2, 3. And remember it's negative because a positive times a negative is a negative. 74.847. How you do it's up to you. But in my mind, this is major because it gives you a reason why the decimal goes where it goes. Like, yeah, there's tons of work over here. Fractions, and you're like, fractions and decimals. Yeah, fractions and decimals actually intertwine with each other. They relate a lot. Lots of extra scratch work. But you know what? It gives you a reason of why something is what it is. Okay, last example. Example number 3. And I'm going to show a new way that you might not have seen of this before. 6.42. Dividing is just a fancy way of doing fractions. I can actually take 6.42 divided by 0.6, and this is actually equal to, well, I can just rewrite it as a fraction. Here's what I'm going to do. I would say flat out, what number can I multiply both of those by to turn them into whole numbers? Either 10, 100, 1,000. So like I want to multiply it by one of these numbers. So I want to move the decimal. If I multiply by 10, so if I times by 10, that'll move the decimal one time. And whatever I do on the bottom, I gotta do on the top. There's one, there's one. Yeah, that's 6 now. But this is 64.2. It's not a whole number yet. So I don't want to use 10. I want to use 100. Notice I'm just adding zeros now. Like no new fancy number, I'm playing with it. I move the decimal one more time on top and on the bottom, which means I have to add a 0. So on top I get 642 divided by 60. Now, it's just a fraction. Simplified fraction, guys. Here we go. Divide top and bottom by, we can go with 2. So why not? 64 divided by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 2 divided by 2 is 1. Divided by, well, 6 divided by 2 is 30. Basically. Here's a real cool trick. 3 plus 2 is 5. 5 plus 1 is 6. If I can add the numbers together and whatever their numerator sum is, I can divide that by 3. I can divide the whole thing by 3. So I can actually divide top and bottom by 3. 3 divided by 3 is 1. What's 21 divided by 3? 7, but I don't put 7 right here because that's only 17. I have to add a 0 because I skipped the 2. I can't divide 2 by 3. So that means I put a 0, but I can divide 21 by 3, so that's 7. Over, well, 30 divided by 3 is 10. Well, if they gave me a decimal, I should probably give my answer as a decimal, but it's dividing by 10. If I have 107 and I divide by 10, I just move the decimal one time. So my answer should be 10.7. 10.7. That should be my answer. I like that way because it gives me a reason for moving decimals. I'm always about a reason, guys. Gotta have a reason to do anything in life. Let's see what happens with the classic. .42 divided by 0.6. If you remember back in the day, back in 6th grade probably, I got to make a whole number out here. So if I move the decimal on the outside, whatever I do on the outside, I have to do on the inside. Think about it. On fractions, whatever you do on the bottom, you got to do on the top. That's just like out here, isn't it? See that connection with fractions and decimals? It's brilliant. Move the decimal one time. So really, I'm going to take 64.2. And remember, I'm just going to put the decimal right there because I know I'm lining up that decimal. 6 goes into 6 one time. I'm going to minus 6, and I'm going to get 0. Cool. 4 comes down. 6 is too big, man. Can't put it in there. Got to put a 0. Don't forget that 0. If I see 1.7, I know you messed up. You forgot that 0. Bring down to 2. 6 goes into 42 7 times. Minus 42, and hey, look, terminating 0. I'm done. So I know 6.42 divided by 0.6 is equal to 10.7. It's 2 different ways of doing it. Takes some time, but I think it's definitely worth it. there's the video for you guys. See you next time.